Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz bin Zul Azri, number matrix AA200535. I am the team leader for Group 4 Section 5 Dynamics. Our topic for today is Principle of Linear Impulse and Momentum. Our group member consists of 4 people, which is Alif Daniel bin Muhammad Faizal, me myself Muhammad Aziz bin Zul Azri, Muhammad Nasrin bin Muhammad Sabri, and Nukman Hakim bin Nizam. We will continue with the introduction part.
Hello, it's me, Nokmat. Okay, for introduction, the principle of linear impulse and momentum is obtained by integrating the equation of motion with respect to time. So this is the equation F equal to ma. So that A we can uh, replace it with dv per dt. So we can integrate this equation to become uh, below equation the f dt equal to m dv. So what is linear momentum? Linear momentum is the right side of the previous integrate equation. So that is called linear momentum. The unit is kg m per s. So linear impulse. Linear impulse is the left side of the equation. So it's called force. Then force is the unit is Newton second. So as you can see the graph, we can direct integrate. We can represent it by that graph. Okay, move to the next background. Okay, thank you.
Alright, Assalamualaikum and hi. My name is Alif Daniel bin Muhammad Faizal. My matrix number is AA2010AA. Next, I would like to present about the case study one that related with the principles of impulse and momentum. As we can see from the picture, the principles of linear impulse and momentum can also be understood through the movement of vehicles on the road. It can be observed through the time that there is a car moving with an initial velocity value and the result is a difference in momentum and a decrease in final velocity during the braking process. Indirectly, there will be a kinetic coefficient between the car tires and the road. The momentum used by a car is directly proportional to the mass and velocity of the car. In addition, the principles of linear impulse and momentum are applied to the needs of cars that produce large momentum while performing the braking process. We can determine also the impulse and coefficient to find the occurrence of an accident occurred by a slip due to a lock tire by using formula principle linear of impulse and momentum. That's all from background of case study one. I will pass to the next presenter.
Alright, Assalamualaikum. My name is Muhammad Nasir bin Sabri and my number matrix is AA200976. Alright, today I will talk about case study 2. Alright. The principle of linear impulse and momentum can also be understood through the path of movement of cargo trains on rails. It also can be observed through a method in which the train moves with a velocity value and will produce a change in momentum. The principle of linear impulse and momentum are much needed to be emphasized in automotive manufacturing because the principle of linear impulse and momentum can determine the final speed for an automobile. Based on the value of mass and force given in the question, we can solve the speed and horizontal coupling force by using the formula, the principle of linear impulse and momentum. Alright, that's all for me. Next presenter.
For case study 3, as we can see in the picture, it is about a bumper car. We can also find final velocity using conservation of momentum and conservation of energy, aside of principle of linear impulse and momentum. So what is conservation of momentum? Conservation momentum, the formula is stated as below. It is formulated from Newton's second law, F equal to ma, and the momentum formula P equal to mv. Then what is conservation of energy? The formula is T1 plus U1 equal to T2 plus U2, where T is the kinetic energy 1 over 2 mv square and U is the potential energy which is mgh. Using these two principle, we can solve the equation.
Okay, for the basic theory, the principle of linear impulse and momentum theory. So okay, this equation is in a vector form. After we uh, the mv1 is the particle initial momentum, and the fdt is a sum of all the impulses. So we plus it, and we can get the particle final momentum. Okay, based on that diagram, we have initial momentum. Okay, we have a impulse. Uh, After we combine it, we can get the resultant momentum. Okay, next. Okay, since the principle of linear impulse and momentum in vector form, so we can resolve it into x, y, and z component scalar equation. Okay, next. So how we solving in that problem? So we give our question. We first we establish the x, y, and z coordinate system. So then we draw the free body diagram. We establish the direction of particle inertia and final velocities, and then we resolve the force and velocity into y, x, and z component. So then the force we integrate to obtain impulses. So that's it. We can get the answer. Okay. So for the principle for the system of particle, so this is the same as the previous, but this is for internal impulses. So when we have ball. So this ball have two forces. The forces left and right. So when we sum it, we get 0. So we can ignore it. Just ignore. So it's just for internal only. So next, we go to conservation of linear momentum. Okay. Next. Okay, this is the equation for solving the question. So the sum of impulse becomes 0. So we can get this equation. Linear impulse momentum. So we can solve the problem when the impulse becomes 0. Okay, that's it. That's all. Thank you.
Moving on to result of calculation and discussion. These two parts, we combine it together because we believe calculation and discussion is related to one and another. So we will continue with the calculation for case study 1.
Alright. Next, I will continue our presentation with calculation for case study 1. So the question is, the 2.0 megagram car is moving with a speed of 90 km per hour when the brakes are applied and all four wheels locked. If the speed decreases to 30 km per hour in 5 seconds, determine the coefficient of kinetic friction between the tires and the road. Alright, first of all, we need to draw the free body diagram based on the given situation to facilitate the calculation while answering the question. Given the value of the car's mass of 2.0 megagram as well as the rate of change of initial and final velocity of the car during the braking process from 90 km per hour to 30 km per hour in 5 seconds. Based on the given question, we need to create a force fraction to determine the required value. The value of the coefficient kinetic energy of the car can be determined by completing the calculation by using formula principles linear of impulse and momentum. Based on calculation from the slide, the first thing that we need to estimate is the value for the initial velocity and the final velocity the car is moving. After that, we need to resolve into x-axis and y-axis. we can determine also the normal force for the car from the x-axis equation. So the normal force that we get from the calculation is um 19,620 Newton. Then the value of the value of the coefficient kinetic energy of the car can be determined by completing the calculation by using the formula mv1x plus fx dt equal to mv2x. So the value of the coefficient kinetic energy of the car is 0.340. 0.340. So I think that's all from me. I will pass to the next presenter.
Alright, I will talk about calculation case study 2. The 28 megagram cargo train moved with 30 megagram, 8 megagram and 6 megagram cargo under pressure F equal to 28 kilonewton on the engine wheel while the cargo train is moving. With the time S equal to 28 second, the speed and horizontal coupling force of the train can be determined. First, we need to divide the free body diagram into two free body diagrams. This is the first body diagram. The free body diagram that we see in figure B, we consider the head train and cargo as a single system, and using this FBD, we want to calculate speed of the train. At the first FBD, we can see the mass of head train is 28 megagram and the weight of each cargo is 30 megagram, 8 megagram and 6 megagram respectively. It has forward force. It is 28 meganewton, and it also has normal force because this is single system. By referring the free body diagram of the entire train shown in figure B, we can write the original formula is F equal to ma, where A equal to dv over dt. This formula is from integration f dt in the respect of the time equal to integration mdv in the respect of the velocity. The formula used to solve the calculation is using x-axis, mv1x plus integration f dt in the respect of the time equal to mv2x. So we put in the value into the formula and we will get v equal to 14.25 meter per second. So the speed of the train is 14.25 meter per second. Alright, this is the second free body diagram. We use this FBD because we want to calculate horizontal coupling force. By using the same step as above, we can get horizontal coupling force is equal to 13.74 kilonewton. So the horizontal coupling force at D between the head train E and the cargo A is 13.74 kilonewton. Alright, that's all for me. Continue to next presenter.
So I will talk about calculation for case study 3. Next.
Les garçons.
A family was enjoying their weekend at the carnival.
Garçons.
They were playing the bumper cars. This case study is about collision head-to-head of the bumper cars. Bumper car A carrying two kids with mass 30 kg and 45 kg collided with the bumper car B, which is driven by an adult with mass 65 kg. Both bumper cars have the same mass of 120 kg. The velocities for both car A and car B before the collision occurs is 2.5 meter per second and 2 meter per second respectively. If no energy loss during the collision, determine their velocities after collision. We assume that there is no friction force and air resistance involved in this case study. So the first step we need to do is the free body diagram. Consider the car as a single system when they are colliding to each other. All forces can plotted as below. We have the normal force for A and B, the force between A and B, and the mg for A and B. So for car A, all the component is listed below. The M total is equal to the mass of kit 1, kit 2 and car A equal to 195 kg, and the velocity of A is 2.5 meter per second to the right. For car B, the total mass is for adult and the mass of car B, which is 185 kg. And the velocity is 2.0 meter per second to the left. Then we go to the next step, which is the conservation of momentum. Using the conservation of momentum, which is MAVA1 plus MBVB1 equal to MAVA2 plus MBVB2, we can get the first equation to solve, which is 47 equals 78 VA2 plus 74 VB2. Then the third step is using conservation of energy. We know conservation of energy formula is T1 plus sum of U1 equal to T2 plus sum of U2. As I mentioned earlier, T is the kinetic energy and U is the potential energy. Since no energy is lost, the conservation of energy theorem gives that the potential energy is zero. So we can neglect it, become T1 equal to T2. So using this theorem, we can get second equation, which is 969.375 equal to 97.5 VA2 square plus 90 VB2 square. And lastly, after we have two equations from the two theorem, we can solve these two equations using calculus. Then we get the answer for VA2 and VB2. For VA2, it have velocity of 1.89 meter per second to the left and 2.5 meter per second to the right. Since the initial velocity of car A is 2.5 meter per second, so 1.89 meter per second will be its final velocity. Same goes to car B. 2 meter per second is the initial velocity. So 2.63 meter per second will be the final velocity for car B. Hence, we get both final velocity for each car.
Okay, so you hear it? It's easy. So after we learn this principle, we can use the principle in our daily life. We can uh, solve our daily life problem. If we doesn't learn about this principle, what happened? Okay, we cannot do heavy work like machinery. We don't know how to how to get the momentum, how to get the velocity, how to get know how many force we want to do the work. So because sometimes force not constant, you know. You know what I mean? Okay, that's all from me.
Other than that, we can also conclude. We can do comparison about kinematics and principle of linear impulse and momentum to solve equation related to force, velocity, and time. We can use these two principles, but we need to determine which is the best for the case study. So if we learn linear impulse and momentum, we can uh, we can choose which is the principle that is suit for the case study. Other than that, if we learn more about the principle of nature, we can be a better humankind. That's all from me. Thank you.